I sort of told you all unit that we're learning something pretty big. And so this is where it really starts. Like common factoring is important. And so it's big in a way, but it's a lot simpler usually. But this is like something really new and really big, fundamental skill. It's good stuff. So we're going to learn how to factor simple trinomials. A trinomial has three terms. So when we get down, these are not, like the examples that are up here are something else, so we haven't seen it what it looks like yet. But it's got three terms, and there's a special way to factor them. And simple trinomials have a special way. So simple trinomials are special kind of factoring. That's what we're learning today, but it's like big, big, big stuff. It's good, good, good stuff. With factoring, as I talked about before, it's always important to connect it to how you got there in the first place. So factoring trinomials is the opposite of multiplying these binomials. So let's remember what happens when you multiply two binomials. Okay, so we're going to do the first one kind of a long way. All right, so this would be x squared plus 3x plus 4x plus 12. Does that feel good to everybody? And hopefully it's familiar that then those two middle terms, oh look, they're like terms, x squared plus 7x plus 12. Right? This is from a couple days ago. This is old news now. But what do we notice? So you could, like, that's a long way of doing it. There's nothing wrong with that. But what do we notice? We notice that this is always 3 plus 4. And this is always 3 times 4. Right? There's your 3, there's your 4. There's your 3, there's your 4. From the question. Right? You get the middle term by adding them. You get the last term by multiplying them. So we can skip that middle step. Let's try the next one. So can somebody do this one for me? Like do it in one step? Who can answer this one for me? Megan? So I think what Megan did is she said, oh look, the middle term is going to be 3 plus 7, which is 10. And the outside term is going to be 3 times 7, which is 21. Very good. Everybody agrees that's the right answer? Everybody's happy with that? Awesome. Okay, what about this one when we're subtracting? Jaden. So this is negative 2 plus 3, which is positive 1. And this is negative 2 times 3, which is negative 6. So in that case, they had opposite signs. So the middle term was the difference between the two. What's the difference between 2 and 3? There's 1 in between them. So a difference of 1. Very good. Who wants to do that last one? Tara. Minus 4x minus 5. So then once again, this is 1 plus negative 5. And this is 1 times negative 5. So the difference between 5 and 1 is 4. So the middle term is 4, negative 4 in this case. And then 1 times 5 gives me negative 5 on the outside. Happy with that? I know this is old stuff, but so everything we do from here on in is based on that. Those 4 questions, what we're going to do is based on those 4 guys. Okay? So if we know that the outside term I got from multiplying and the inside term I got from dividing, can I work backwards and fill in these blanks? What should I put there? Don't shout it out. How many people have an idea of what I would put there? Riley, what do you think? 1. How did you get that? 1 plus 2 is 3, and 1 times 2 is 2. Awesome. And it gave you the 2, so you can kind of work backwards from that too, right? Just FYI, these questions are just thinking questions. These are not what our questions will look like. Fill in the blank questions. This is just getting us there. But it's helping us think in the right way. Okay, who can do the next one? Who thinks they have an idea for the next one? Kristen. -3. So plus -3 is a little bit weird looking, but that's okay. Again, these are not the kinds of questions. We're not worried about how we write it. These are not the kinds of questions that we're doing. This is just helping us get there. How'd you get that? 2 plus -3 is -1, so -1x. And 2 times -3 is -6. Awesome. Very, very good. Alan, question? You want to do the next one? Okay, so hold on, don't shout it out yet. So for the next one, you don't have either number. So you have to figure out both. There's lots of numbers that add to 6, like 1 and 5. But they don't multiply to 8, do they? How about 10 and -4? They add to 6. They do not multiply to 8. Okay, so don't say anything, but how many people, hands up, think they know the two numbers? Ooh, lots of people. It's fantastic. Alan, you want to tell us what they are? 2 and 4. How'd you get that? 2 plus 4 is 6. 2 times 4 is 8. That may seem easy, but this gets a little bit trickier. But fundamentally, that's what we're doing. Is two numbers that multiply to this constant at the end and two numbers that add to the x term in the middle. That's factoring simple trinomials in a nutshell. Okay, so to summarize, write this down so that when you leave class today and you go home and you pour yourself, a cup of milk or something? Is that what you have when you get home? Something refreshing like that? You have a cup of milk, maybe a cookie. And then you kind of forget what happened in class today because you're sick to your stomach from drinking a cup of milk and you're lactose intolerant. So then you're like, how do I do this? Then you're going to look back at your note, and this is a quick little reminder of how to do it. So this direction, folks, is called expanding. We expand and then we simplify. This direction we call factoring. It's the opposite. It is breaking something up into its factors. Kind of like if I took 12 and I broke it up into its factors of 3 times 4. Something times something. Okay, so I take this expression and break it up into its factors. That's why we call it factoring. It is the opposite of expanding. I expand two binomials to get a trinomial. I factor the two trinomials to get the trinomial, to get the two binomials back. And really what it boils down to is I'm looking for two numbers that multiply to 20 and add to 9. So I look at this trinomial. 20 is my constant. 9x is the middle term. Two numbers that multiply to 20 and add to 9. If this was written x squared plus 20 plus 9x, it's still two numbers that multiply to 20 and add to 9. It doesn't like all of a sudden become, right? You add to the x term, not to whatever's written in the third place. Now, you'll never really see it written like that, but just so you know, it's the constant that they're always going to multiply to and the x term that they're always going to add to. Any questions? All right, now we're going to actually do one. from start, this is what your question will look like. And it'll say factor fully. From start to finish, this is how you would do it. Put your pencil down for a moment and watch. I write my equal sign because I don't want to forget that. This is a trinomial. I know from all these patterns that we did up here that a trinomial came from multiplying a binomial, multiplying two binomials. I know that. So I know that this is going to look like this after I factor it. And this tomorrow we're going to do complex trinomials, but this is just simple. So simple trinomials always just have x and x. So I know that. So I start by writing that. So you can go ahead and write that down. What I'm trying to say is there's no other way to do this. If you're multiplying binomials, you can just step by step multiply each part. Multiply the x's. Multiply the outside parts. Multiply these parts, and add whatever you can together. You can do it step by step. There's no step by step to factoring. You have to know that that trinomial, when you factor, is going to look like this. And it's a really good idea. It jogs your memory. It puts your brain in the right kind of position to factor if you start by writing that down. Bracket, x, bracket, bracket, x, bracket. Now, who can tell me what I'm looking for? Don't tell me the answer. Tell me what I'm looking for.
Something that multiplies to 5 and adds to 5 and multiplies to 4.
Right, very good. Good correction, too. I love it. So they multiply to 4, and they add to 5. And how many people think they know what those are? Jacob, what do you think? 4 and 1. I thought it was 1 and 4. Same thing. Anybody thinking 1 and 4? Same thing, right? X plus 1 times x plus 4 would also be fine. Any questions about that? Put your pencil down and watch. Do not write this down, what I'm about to do. This is what people like to do. So they're practicing their factoring and they're doing it. They're like, oh, okay, that's factor. Oh, look, binomials. I know how to do that. This is x squared plus x plus 4x plus 4. X squared plus 5x plus 4. Done. No. You went the wrong direction. This is what I was talking about the other day with like that cryptic thing about questions and answers. What's a question? What's an answer? And people think that it's like always in one direction. But that's not true. When you're told to factor, this is your answer. That was your question. You don't do that and then undo it again. If you left this as your answer on a test, then it's wrong. Okay? Now this is a great check, but don't do it under your work. Do it on a scrap piece of paper. Do it in the margin. Do it on the back. Do it somewhere else. It's a great idea to check. I'll talk more about that later. It's a great idea to check, but don't do it under the question, because then it looks like you think that's the answer, and it's not. You were supposed to factor it, and you didn't. Alan.
Where did you get the 4 and 1 up there?
Remember, factoring is all about, so in this case, two numbers that multiply to 4 and add to 5. What are those two numbers? 4 and 1. That's how you factor. There's no, I'm going to show you something. If you can't come up with the numbers, I'm going to show you how to organize your thinking a little bit better. But there's no like method for doing this. It's like you got to just practice and you just get good at it. And eventually you just like, oh, it's this and this. Oh, it's this and this. Oh, it's this and this. And you just solve it. Okay, let's try another one. Okay, so first of all, I know that it looks like this. I know that because I practiced these a whole bunch of times. And I just know that that's what happens when you factor. That's part of this process, knowing that. So I start with that. And how many people think they already know the answer? Great. So a lot of people are already on the right track. Like you know two numbers that multiply to 12 and add to 8. It's not always this easy. It certainly gets harder. Let's say, for some reason, you were stumped and you couldn't find these numbers. What would you do? So I'm going to show you a way that you can organize your thinking. You might only use it when it's really big numbers. You might only use it on a test because sometimes people get nervous on tests and the brain stops working and you're like staring at the page, and you can't get the numbers. What do you do? So this is what you can do. You set it up as a table. So we always start with what we multiply to. And then I'm going to worry about what they add to. And the reason is because there's an infinite combination of numbers that add to 8, but there's only a few pairs of numbers that multiply to 12, because we're not talking fractions here. We're just talking integers. So if I start with if I can come up with the whole list of all the numbers that multiply to 12, and then I can figure out, well, which one of them adds to 8. So I'm going to start with 1. 1 times what gives you 12? Ooh, this is a tricky one. Rachel. Nice. And then I'm going to move on to 2. 2 times what is 12? 6. If you don't know your times tables, you have to get out your calculator and try these things. Then I'm going to go on to 3. 3 times what is 12? 4. Then I'm going to go on to 4. 4 times what is 12? Madison? 4 times what is 12? 3. Oh, you already had that one. 3 and 4, 4 and 3. Do you have to do both? Yes, you do. What about 5? 5 doesn't work. Right? Nothing times 5 gives you 12. 6 and 2. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11 doesn't work. 12 and 1. And then all I do is add them. In this case, other questions are a little bit different. 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. 4 plus 3 is 7. 6 plus 2 is 8. I know it looks like we did twice as much work, but trust me, when it starts getting a bit harder, you'll see. So there's 2 possibilities in this case. X plus 2 and x plus 6, or x plus 6 and x plus 2. Same thing. So if you can't just get the numbers, which for the easy ones I know you can, but sometimes they get harder and you can't, learn how to write the table. But by the end of this unit, you probably shouldn't be using the table anymore. It's slow, and you eventually want to get really good at this. Alan?
Does it matter where we put our numbers? Let's say it can be 6.
No. Doesn't matter. X plus 2, x plus 6 is the same as x plus 6, x plus 2. In this case, it doesn't matter which way you write it.
Which one do you know which one multiply? Like adds to this number and multiplies?
Because it always multiplies to the constant, and it always adds to the one with the x. Yeah?
Will we ever be factoring trinomials with a distributed property?
What do you mean by that?
Like up with the last example, will we ever factor 2 open bracket x minus 2 and then continue on?
Yes, but don't worry, we'll see what those look like later. Yeah. Okay, let's try another one. What's different about this guy? Trade him. There's a negative. Starts the same way. What do I have to consider when there's a negative? What's that telling me? Exactly one of them, and one's positive, right? One has to be positive, one has to be negative, so that when I multiply them together, it gives me a negative. Very, very good. So I'm going to build my table again. You might already know the answer. I don't know, but I'm going to build my table, and I'm going to try this. So I'm looking for 2 numbers that multiply to negative 30 and add to positive 7. We'll start with 1 and 30. 2 and 15. 3 and 10. This is why you need to know your times table as a factor. 4 doesn't work. 5 and 6. 5 and 6. 7 doesn't work. 6. Oh, 6 and 5. I skipped 1. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 and 3. 15 and 2. 30 and 1. You have to make sure that you don't skip any. If you skip one, that's the answer, then it's gonna take you a whole class and you'll never get the answer. So you gotta be really careful that you get all the factors. Jaden told us Anang told us that they have to have different signs. So I'm gonna put a minus sign between them. I'm not adding them together, I'm subtracting. 1 minus 30 is negative 29. 2 minus 15 is negative 13. 3 minus 10 is negative 7. Negative 1, 1, 7. I found it. That's why you have to do it twice. That's why you have to do it up and down. So it's x plus 10, x minus 3. Two numbers that multiply to 30 and add to 7 are 10 and negative 3. 10 times negative 3 is negative 30. 10 minus 3 is 7. Does that make sense? Yep.
Do we have to show this portion?
You absolutely do not have to do the table. You don't have to show it. If you're halfway through writing the table and the answer comes to you, stop and write the answer down. 100% you don't have to write the table. But if you ever get stuck, my suggestion is, we'll talk about this a bit more tomorrow, but don't stare at factoring questions for too long. If you're stuck and the answer's not coming after like 8 seconds, start writing something down. Otherwise, you could stare at it for 5 minutes and the answer won't come to you. Sometimes your brain just, I don't know, there's just a little hiccup and you just don't see the answer. So you do have to have a way of working towards the answer when it doesn't pop into your head. Once you've done enough of these, you may just be able to get the answers, right? We all work a little bit differently. Okay, one more. Try this one yourself. The first thing that should go through your head is I'm trying to find two numbers that multiply to something and add to something. That's the first thing that should go through your head, right? You get like that sentence should go through your mind. Two numbers that multiply to, add to, or have a difference of, and then you come up with those two numbers. The other thing you can do, like if you don't want to write down the table, like if you find after working today that you're not very good at this, learn how to do the table. It's the only way that you're going to get any better at it. But if you don't want to write it down, you can just come up with things. Things that multiply to 16, 1 and 16, 4 and 4. Like just start thinking of things. What's the answer? Riley.
X minus 8 and x plus 2.
8 times 2 is 16, and 8 minus 2 is 6. So they multiply to 16, and they have a difference of 6. We wanted them to have a difference because the product, the thing they multiply to, is negative. One has to be positive, one has to be negative. So when I add them together, it's actually a difference. The difference between 8 and 2 is 6. Why is the 8 negative, Riley? Can you explain that?
Yeah, because positive 8 plus 2 would be 10, not negative 6. And positive 8 times 2 would be positive 16, not negative 16.
How come the negative isn't on the 2?
Because then positive 8 minus 2 is 6, not negative 6.
Yeah, very, very good. Good. All those connections are important for this factoring. Thinking about all those things. It's almost like you're a detective. You got to think about all these different little tips and indicators at the same time. Okay, let's try one more. Go for it. Try it yourself. Remember what I said. It's always a good idea to write that down because you know that's what it's going to look like. That helps put your brain in factoring mode.
So, the relationship between negative and positive and positive tells you a lot about how you because I'll do a summary afterwards.
How many people think they have an answer? I like it. I see people writing down factors, just trying to figure out what multiplies to 15. Very good, very good. Okay, who wants to answer this one? Jaden. Can you tell me how you got that?
I just thought of like times what was 15.
Yep.
3 and 5.
Yep.
3 and 5. Negative 3 and negative 5. Equal 8, negative 8.
Okay, good. So how did you know they both had to have the same sign?
Because 15 is positive. So, and if anything with the same sign, it would equal positive.
Okay, very good. Okay, so let's just summarize. So put your pencil down and pay attention quickly. This is really important. If it hasn't clicked for you yet, the first thing you're looking at is the product. Okay, the sign of the product. If it's positive, the two numbers are either both positive or both negative. You don't know which yet, but they have to have the same sign because that's the kind of thing that multiplies to a positive. So they're either positive 3 and positive 5 or negative 3 and negative 5. That's all I know, right? Because the product is positive. Same sign. Then I look to what they add to. Well, that's negative, so they must both be negative. So two numbers that multiply to 15 and add up to 8, and they're both going to be negative. If it was two numbers that multiply to negative 15, it would have to be like negative 2. Oh, that's not going to work. Shoot, sorry. It would have to be like x squared minus 2x minus 15. So these ones have that the product is negative, so they have a different sign. So again, in this case, it was 5 and 3, but it's the difference of 5 and 3. Does that make sense? So you got to look at the sign of the product. You got to look at the sign of the sum. And then you have to come up with two numbers that multiply this, add to this, or multiply to this, the difference of this. Does that make sense? Any questions? Okay, before we do the next example, we're going to do one more example before I let you practice on your own, but we're going to do a different kind of activity first. So listen up carefully so that you know what you're supposed to do. Secretly, you have to hide it from the person beside you. You have to come up, trust me, they're going to try to look at what you're doing and cheat. You have to come up with your own question. So pick two numbers, add them, and multiply them. And you're going to try to write this, and then you're going to give it to them, and they're going to factor it. So you have to come, and not every question, you can't just make a question up like this. Like you can't just go, oh, I'll do x squared plus 5x plus 17. Because there aren't two numbers that multiply to 17 and add to 5. So you have to make up this question in an intelligent way. You have to pick two numbers, add them, pick the same two numbers, multiply them, and write the trinomial so it works. Everybody understand that? Your first time trying it, it might not work. Then you give it to the person beside you and see if they can solve it. Okay, go.
messed up.
Yeah, that's a good one. That's a special case.
Write it out again.
24,676.
Oh, I see. You figure it out on the fly?
On the fly.
What I would actually probably do in that case is I would start thinking of numbers that add up to 315, which is like a whack. But I would
Actually, I didn't check it on the back.
Are you sure you got this? 200. You should look that one here. The difference is 315? You sure, right? Because 100 and, let's say there's 100 times.
It doesn't work because it's not 100 and
Like 65.
there you go. There you go.
The numbers are what should I say?
You don't remember your numbers?
Did you come up with one?
Yeah, I'm using it right now, but I messed up.
Ah, see, it's tricky, isn't it? Okay, that's okay. Fix it. So fix it.
Wait, I got from that.
I added the one.
You know, 146, what's the third time that we
Do you want me to give you a little hand?
Doesn't matter. You really should add it.
It works out.
Do we switch?
I was actually pretty close. What did I say?
Yeah, that needs to be 64.
I said 165, which isn't going to work.
Yeah, this needs to be 64. This is a,
Were you impressed? He was like, oh my God, that was a 65.
Yeah.
It would have only taken me a few more tries.
I mean, that's what the one is like, but it's 13 and 13. So I gave it away to you 2 times, and I wrote 15.
There's just no point. Like I could even do that in my head, but it would just like it would just take too long. Why not? Okay, awesome. That looks really good. It's hard, isn't it? But it's a bit of a hard process. But I think it really helps you think about those connections. So that's good. So if you didn't get it yet, keep trying. Try another one. We'll have a few more minutes maybe at the end to try a little bit more. Okay. One more example. I just want you to watch as we do this one together. So take a look up here. Example number F. What's different about F? Take a look up here. What's different about F, Rachel? Ah, there's a y in there. There's a y squared and a y. It's different. That means my brackets weren't just like x plus 3, x plus 5, because that wouldn't give me that. But that's okay. You won't do quite as many like this, but you'll do some like that, like this, and they're all going to work. So let me show you how I would do a question like this if I was you. I would start the same way. Who can come up with two numbers that multiply to 36 and add to 5 or negative 5? Because it's negative 36, so they're going to have a different sign. So you're going to have a difference of 5. So two numbers that multiply to 36 and have a difference of 5. 4 and negative 9. So minus 9 plus 4. Does everybody agree that's the right answer? So see how I did it the same way. Now I look at this and I say to myself, and anybody who's not listening right now, you're going to get to these questions in the homework and you're just going to be lost. So please pay attention. And you think about what do I add to this to make it work? So I want negative 9 times 4 to give me y squared. Means I need each of them to have a y. 9y times 4y is 36y squared. And then when I multiply them with the x's, I get the xy in the middle. So sometimes we get a little bit of a trick where the question looks a little bit different. You're going to factor it the same way. Two numbers, multiply this and add to this. And then you just kind of make it work. And there's only a few different ways that it's going to look. Like it usually looks kind of the same. Okay? So there's a few questions like that in the practice worth trying. These are the hard ones. These are the ones that if you skip over, you're really losing out on an opportunity to like push yourself a little bit further. So if you can do those easy ones, that's great. Now try these harder ones. Because even if you don't quite get it by the end, trust me, it makes the easy ones even easier. All right, there's your practice.